Hello everyone. Uh, Myself Indian Najibullah. I'm going to present about the last chapter, uh, RFIC module design tool. That is MMIC oscillator. So let's get into the deep of the presentation. So here is a simple RFIC oscillator system. So a MMIC oscillator is a small integrated circuit that generates microwave signals. And these oscillators are typically used in applications requiring high frequency performance, such as radar communication and instrumentation, and highly effective. And these MMIC oscillators offer advantages like small size. Uh, that's the reason these MMIC oscillators also low cost and high reproducibility. So what is the key features? The key features are high frequency operations. MMIC oscillators are designed to operate at microwave frequencies, typically in the range of 300 MHz to 300 GHz. And what is the integration system? The components of the oscillator are integrated onto a single chip, MMIC chip. Uh, this chip, MMIC chip, actually low cost, and the size is also small size. And reproducibility, MMIC fabrication processes led to consistent and reliable oscillator performance. MMIC oscillator design. So designing a MMIC oscillator involves several key steps. First, we have to choose an oscillator topology. Based on this topology, digit frequency and performance requirements. And then we have to select appropriate active devices, such like transistor, and beside the active devices, we also need to select the passive components, the inductors and capacitors. Next, we need to design the negative resistance network, which is crucial for oscillations. Finally, we need to use simulation tools to analyze the circuit and optimize it for performance. So now, time comes for choosing an oscillator topology. So there are two major topologies. One is negative resistant oscillator, another one is VCO, voltage control oscillator topology. And there is also other topologies like Colfit's, Pierce, and clap oscillators that can also be used, but they may not be suited for MMIC implementations. So what type of active and passive components used for oscillators? So active components are the transistor. Different transistor like MESFETs, PHEMTs, and HBTs can be used. On the other hand, for passive components, you can use inductors, capacitors, resistors. You can also use the varactor diodes. So now time comes for designing the negative resistance network. Um, Analyze the circuits, small signal impedance and loop gain. The goal is to create a negative resistance at the desired operating frequency. Uh, Large signal analysis. Due to do the large signal analysis, we need to use a nonlinear simulator, harmonic balance simulation to model the circuit's behavior with the nonlinear elements. There is a specific chart, that is a Smith chart. The Smith chart can be helpful for visualizing impedance transformation and finding the appropriate load reflection. Simulation. In order to do the simulation of this oscillator, we use commercial software like ADS, Agile Design System, and Subdesigner or WSIM. So simulation types, there are two types of simulation, small signal simulation and harmonic balance simulation. And after simulation, we need to do optimization and then layout fabrication. The layout should be optimized for power delivery, signal integrity, and noise reduction. The fabrication process, CMOS, gallium arsenide, or SiG will determine the available materials and fabrication types. And this figure actually describe all this process I have described in my oscillator. And that's all. Thank you everyone for your kind attention.